Okay, so now we're going to use that combination formula. So when we have a combination of n things taken r at a time, it's n factorial over n minus r factorial. So similar to the permutation formula, but then you're still dividing by another r factorial, okay? Now, one thing that I always remember is that those two numbers are going to add up to be n. Think about it. N minus r plus r is just going to equal n, right? Equals n. Okay, that always helps me when I do these problems. A three-person committee is needed to study ways of improving public transportation. How many committees could be formed from the 8 people on the Board of Supervisors? Okay, so we're finding a combination. It's a committee. We don't care which order we pick them in. We have 8 people to choose from. And how many do we want on the committee? 3. Okay, so 8 people, we're taking 3 at a time, and it's a combination. So in our formula, we're going to have 8 factorial over 8 minus 3 factorial times 3 factorial, or 8 factorial over 5 factorial, 3 factorial. So remember, that's why I was talking about those two numbers, the 5 and the 3, add up to be the n. Okay, so that might be helpful. Now we talked about how to simplify these, but remember, we're going to count down the 8 factorial, 8 times 7 times 6 times 5 factorial. We're going to stop at the larger number. 5 factorial. Those are going to cancel. Now, the 3 factorial, though, that you have to write out. So times 3 times 2 times 1. We usually put the 1 even though it's not necessary, but the 5 factorials cancel. Those are out. And then I usually see if there's something I can divide. Well, 3 times 2 is 6, right? So I'll cancel the 6's. That makes my calculation easier. Looks like I'm getting 56. So there are 56 ways we could get that committee. Okay, that's that example. In poker, a person is dealt 5 cards from a standard 52 card deck. Now, a lot of probability problems actually have to do with a deck of cards. And usually they have a standard deck of cards. If you don't know anything about cards, it might be helpful to know a little bit. The standard deck, there's 52, and there are 4 suits, clubs and diamonds and hearts and spades kind of look like that. Okay, so if you know about cards, then you'll know this, and there's 13 of each suit. So it goes ace, king, queen, anyway. It goes ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then you have your face cards, jack, king, queen. But and jack, queen, king. And a lot of people know this, but I found when I've taught probability in the past, there's always somebody that's like never played cards before. Anyway, that's just a little bit of information that might be helpful too. Not this problem, but maybe later on. Okay, we only have one section after this. Okay, the order in which you are dealt 5 cards doesn't matter. So you get, they're dealing you 5 cards. It doesn't matter which one you get first. How many different 5-card poker hands are possible? Okay. So it's a combination problem. We have 52 cards to choose from, and we're taking 5 at a time. So each hand is 5 cards. Okay, so we put that in our formula, 52 factorial over 52 minus 5 factorial times 5 factorial. Okay, that's going to be 52 factorial over 47 factorial, 5 factorial. And that's going to be 52 times 51 times 50 times 49 times 48, whoops, 48 times 47 factorial. Good thing we don't have to write those out anymore. And the 47 factorial, we're not going to write that out because that's going to cancel. But then the 5 times the 4 times the 3 times the 2 times the 1, write that out. Okay, 47 factorials cancel. 5 times 2 is 10, and 10 goes into 55 times, so I could say that. 4 goes into 52 13 times, and 3 goes into 51 17 times. You don't have to do it this way. You could find a different way to do it, but somehow I have to get this math in there. Okay, so that's what I want to put in my calculator here. 13 times 17 times 5 times 49 times 48. Okay, so there's a lot of different hands you could get when you're playing poker. 2, 5, 9, 8, 9, 6, 0. So there's 2,598,960 different hands you could get when you're playing poker. All right.